Hey guys, welcome to the Swift deep dive on protocols. In this deep dive, we're going to be talking about what Swift protocols are and what they allow us to do. So the way I like to think about protocols is imagine it as a certification that you have in your CV or your resume. So for example, in my LinkedIn profile, I've got a bunch of certificates that I've listed. And one of those certificates is something called Advanced Life Support. So this is something that every doctor in the UK has to complete. And it's a 2-day course where we learn a whole bunch of things, including how to deliver CPR to resuscitate people who might have had a cardiac arrest. Similarly, in Swift, we can create these protocols or certifications, if you will, that have a bunch of requirements. And when our classes or our structs adopt this protocol, it means that they are able to meet these requirements and have these skills. For example, performing CPR or resuscitating somebody who's unconscious. So the way that we define our protocol starts with the protocol keyword. And then we give it a name, and similar to structs and classes, it's also named starting with a capital letter. And then in between a set of curly braces, we can define the requirements of this protocol. So let's take a look at this in more detail. I'm going to head over to Xcode and create a new project, and I'm going to select the macOS command line tool to be able to allow us to see multiple files. I'm going to call this product name protocols demo, and then go ahead and hit next, and then you can save it wherever you want. Now inside my main.swift, I'm actually going to delete everything that's in there because we don't need any of it to write the code. Protocols is a fundamental aspect of Swift and it doesn't rely upon anything else. Now let's write some code to see what problems protocols can solve. The first thing I'm going to do is I'm going to create a new class. And my class is going to be a bird class, and I'm going to define a bunch of things that birds can do. So for example, birds can usually fly. And so I've got a fly method in my bird class. And when my bird flies, all that it does is it flaps its wings and it lifts off into the sky. So I'm going to create a very simple print statement to represent this functionality of a bird. Now, in addition, if a bird is female, then they can also lay eggs, right? So let's create this lay egg functionality where we check to make sure if our bird is female, then in that case, we can go ahead and print the bird makes a new bird in a shell. So here we've got our bird class created. And based on what we learned in our classes deep dive, we know that we can inherit from different classes. So if I created another class, let's say I create a eagle class, and it's going to be inheriting from the bird class. So now I've got this eagle subclass, which inherits from my bird class. The eagle now gets access to everything a bird can do. So for example, let's create our own eagle. Let's call it my eagle. And it's going to be a new eagle object created from the eagle class blueprint. And then I could say, well, my eagle, you can fly, my eagle. If it's female, it can lay eggs, and we've set everything by default as female. So our eagle is able to fly and lay eggs. Pretty simple so far. Now, in our eagle class, let's say that our eagles are able to do something a little bit more specialized that maybe not all birds can do. Maybe it can also soar. So our eagle is able to take advantage of the air currents, and using the warm air, it's able to glide through the air using these air currents. And not all birds are able to lock their wings and do this, apparently. Now, our eagle is also, in addition to everything it got from the bird class that it inherited, it's also able to soar. So now we've created our bird class. We're able to inherit from our bird class, and that's all just a review so far. At this point, you might be wondering, well, where's the problem here? This is a really good time to use inheritance, right? Well, let's say that a couple months down the line, we create another class, my penguin class, which is also going to inherit from the bird class. Penguins are indeed birds. They have wings and they have feathers. And penguins, in addition, can also swim. So my penguin is able to paddle through the water. So let's say that we create an object from our penguin class. We'll call it my penguin. And this is, of course, created from the penguin class, and we initialize it. And now my penguin is able to lay eggs, it's able to swim, but curiously, it's also able to fly. It inherited that method because it's a bird. But as you may already know, penguins can't actually fly. Their wings are far too small to be able to support themselves in air. Now we have a bit of a problem, right? We want to be able to define the penguin as a subtype of bird, but we don't really want it to inherit the fly method. So this is the first problem we run into. Our penguin is inheriting some functionality that it shouldn't have. And this can lead to unintended consequences, like a flying penguin. Let's say that we had a flying museum, right? Let's call it flying museum, and let's create it as a struct because we don't need to inherit anything. We don't need any of the class features. So let's say that we have our flying museum, which puts on these flying demos every so often. And in these demos, it takes a flying object, so it has to be able to fly to be able to do this demo. So the flying object, we're going to say it's of type bird, because we know that all birds can fly. They have this function fly in their class definition. So now, when our flying museum puts on the flying demo, well, all it does is it collects all of these things that can fly, and it gets the flying object to fly. So now let's create our museum, which is a flying museum, and our museum puts on a show, a flying demo. So let's huddle up all of our birds that we have access to in our museum, and let's get my eagle to be passed in as the input to the flying demo. So now if I run this code as it is, you can see that once it's done running, I get the bird flaps his wings and lifts off into the sky. So the only reason why I'm able to do this is because I was able to pass my eagle, which is an eagle type, into the flying demo as a flying object, because the eagle class inherits from the bird class, and therefore it's also a bird type, which therefore satisfies the data type of this input. So it's able to be used in my flying demo. Now, similarly, if I create my penguin and I pass in my penguin, and when I run my code, we get a flying penguin and a very surprised audience at the museum's flying demo. This is the kind of unintended behavior I was talking about. The entire code base assumes that all birds can fly, but we have one bird that clearly shouldn't be flying. So the problem is that we're relying too heavily on inheritance and subclassing. Say your app has become a huge hit and now you want to have flying behavior in other parts of your code. Well, birds shouldn't be the only thing your museum is showing off in the flying demo, right? So how would you get that to work? Let's say that I had a structure that's an airplane. And my airplane, well, I also want to say that, well, airplanes can fly, right? So at the moment, the only things that can fly are birds. That's the one that has the fly method implemented. And if I want to be able to use my airplane in my flying demo, well, then it kind of has to be a bird type, because that's the only thing that I can put in here. If I just had an airplane struct that I created down here, let my plane equals airplane, and I try to pass in my plane in here as the input, well then I'm going to get an error because this has a type of airplane which is not in any way related to type bird, which is what I'm making a requirement as the input type. So what can we do? Well, we could force our code to work by making our airplane a type of bird. But now we have a problem because structures cannot inherit. So let's go ahead and fudge our code a little bit more and turn our airplane into a class to make it inherit from bird. So now that works, but let's see what happens when we put our plane into the flying demo. It says that the bird flaps its wings and lifts off into the sky. But actually, wait a minute, it's an airplane. What's going on here? Well, it's because the plane inherits from bird, which has the implementation of fly, and fly says that the bird flaps its wings and lifts off into the sky, which is fair enough for birds, but it's very weird for an airplane to flap its wings. So while we could, let's say, override our methods, fly, and, for aeroplanes, we could print instead that the airplane uses its engine to lift off into the air. And now I've kind of forced my code to work because this is now what we're getting in our flying demo. But there are headaches with this way of doing things. For example, my plane is now able to lay eggs, which makes absolutely zero sense whatsoever. So how can we solve this problem? How can we separate the flying behavior from the bird class? How can we have both classes and structures that can fly? Remember that inheritance only works for classes. So maybe we shouldn't be using inheritance to get hold of the flying functionality at all. And this is where protocols come to the rescue. So let me just clear up my code a little bit to make it easier to see what's going on. And right at the top, I'm going to declare a protocol. The name of my protocol is going to be called CanFly. And this is basically like the certificate that I mentioned before. So everybody that can fly, they've gone to the flying training, they have this capability of flying. But in order for you to be someone that can fly or something that can fly, well, we have some requirements. You must be able to implement a fly method. Now, notice how this fly method that goes into the protocol doesn't actually have an implementation. It doesn't have a set of curly braces which defines how it should be flying. And in fact, if you try to do this, Xcode will give you a warning saying protocol methods must not have bodies. So it only has this part. It can't have any curly braces and any implementation. Now that we've created this CanFly certificate with a fly method that must be implemented by everyone who says that they can fly, we can now go ahead and delete our fly method from our bird class because not all birds can fly. And instead, we can say that our birds which can fly, our eagle class, for example, well, they're going to adopt the CanFly protocol. And as soon as we do this, we get an error from Xcode telling us that you've said that eagles can fly, but you haven't actually implemented a fly method in here. So if we click on this and we say fix, well, then it's going to add the fly method that is required by this CanFly protocol. And in here, I'm going to add a print statement that says the eagle flaps its wings and lifts off into the sky. So my eagle can fly because it implements the fly method, so it satisfies the requirements of my protocol. So the eagle now has this protocol or this certification. And my penguin is not going to get this can fly certification. It's just a bird. It has feathers, it has wings, it can swim, it can lay eggs, but it can't fly. But my aeroplane, on the other hand, now no longer has to be a class. It can be a struct because we actually don't need to inherit anything. Instead, it's also going to adopt the CanFly protocol. So protocols can be adopted by structures or classes. It's not like inheritance. It's not limited to classes. So now my aeroplane has this can fly protocol, so it must implement the required method, which is flying. If you say that you can fly, you must have an implementation. So the airplane uses its engine to lift off into the air. And now in my flying museum, rather than limiting my flying demo to using flying objects that are birds, I'm going to use a different data type. I'm going to use the can fly protocol as a data type. So now I'm saying that when my flying museum puts on a flying demo, it requires a flying object that is something that adopts this protocol, because I know that when they adopt this protocol, they definitely have a fly method implemented. So I'm pretty sure that I'm not going to embarrass my museum by trying to demo a object that can't fly. Now down here, my plane can no longer lay eggs because it's now just a simple structure that is an aeroplane, but it does adopt the can fly method. Now my eagle is able to fly. My penguin is not able to fly, but it can do all of the other things that birds can do because it's still inheriting from the bird class. But my aeroplane is now able to fly. And more importantly, when I put on my flying demo at my museum, I can now pass in my eagle, which is able to go in here because it adopts the can fly protocol. I can also pass in my plane because it also adopts the can fly protocol, but I can't pass in my penguin because it does not adopt the can fly protocol. So now, instead of using inheritance, where I'm saying my eagle inherits from the bird class and my penguins inherit from the bird class, and if birds are able to fly, then all the subclasses of birds, eagles and penguins, all get this capability, which it may or may not actually need. But on the other hand, when my aeroplanes actually need this can fly ability, it can't really inherit from birds because it doesn't satisfy the other things that birds can do, like laying eggs. Now, because we've learned about protocols, we can make our code much better. We can simply adopt that can fly protocol everywhere where we need that capability. So our airplanes become a type that can fly, our eagles also become a type that can fly, and it means that we're assured that when we use an eagle or when we use an aeroplane, because it's marked as can fly, it will definitely have a fly method implemented. This is our protocol in action. And as we mentioned, structures can adopt protocols, classes can adopt protocols, but you can also adopt multiple protocols. All you have to do is after the name of your structure or your class, you add a set of colons and you add your protocols one after the other, separated by commas. Now, if you were creating a class and it needed to be able to inherit from a superclass, well, in this case, your superclass comes first. So it's going to be the name of the class, colon, the name of the superclass, and then the protocols come after the superclass, separated again by commas. If you'd like to know more about protocols and how they work in detail, I recommend browsing through the Swift language guide on protocols. As always, you'll find a link in the course resources. But let's get back to our app. So now that we've seen what protocols are, we can see that our UI text field delegate is in fact just a protocol with a whole bunch of requirements. And those requirements are methods for implementing the text field should begin editing, the text field should end editing, etc. And all of these things. But why is it a delegate? And how is it able to trigger all of these delegates? And what does it mean when we set the search fields delegate as this current class? Well, we'll explore all of that, by doing another deep dive in the next lesson where we look at the delegate pattern using Swift protocols. So for all of that and more, I'll see you on the next lesson.